Problem 4.3 says the brain weights of a certain population of adult Swedish males follows approximately a normal distribution with mean 1400 grams and standard deviation 100 grams. So remember, this is a shorthand for saying normal with mean mu equal to 1400 and standard deviation equal to 100 grams. This is just a shortcut way of writing that. A asks, what percentage of brain weights are 1500 grams or less? Okay, so this is probability that y is less than 1500 grams. And so here is our picture. We are centered at 1400. We look for 1500. And we want to know what is this area over here. So we do z is equal to 1500 minus 1400 divided by 100. And once again, z is equal to y minus mu divided by sigma. So here we have 100 over 100, which equals to 1.00, and the area to the left of z equal to 1.00, we look up right here, 1.00, that area corresponds to 0.8413. So the answer there is 0.8413. And just erase that. I'm going to put 8.8413. B asks, between 1325 and 1500. Okay, so in our picture here, we're centered at 1400. We draw a line at 1500, and we draw a line at 1325. And we want to know the area in between. Okay, we found out the area to the left of 1500. So this part, that's 0.8413. To find the area in between, we're going to subtract off this part, which is the area to the left of 1325. Okay? So, to do this, we set z equal to 1325 minus our mean mu 1400 divided by 100. We get negative 75 over 100. So we get negative 0.75. Look up in our table, negative 0.75. That corresponds to 0.2266. Area is equal to 0.2266. And so the difference in this part is going to be 0.8413 minus 0.2266. And that is 0.6147. So the area between 1325 and 1500 is equal to 0.6147. C asks 1325 or more. 1325 is less than y. Okay, so we want to know what the probability is that we have 1325 or more. Okay. And once again, from the previous part, we had z is equal to negative 0.75, and that corresponds to an area of 0.2266. The area over here is 0.2266. So the area over here on the right hand side is going to be 1 minus 0.2266. 0.2266, which is equal 1 minus 0.2266, 0.7734. So the probability of 1325 or more is going to be 0.7734. D asks, what percentage of brain weights are 1475 grams or more? Okay, so here I put the y over there, but you can also put y greater than 1475. Okay, I want to know what that is. So again, our normal distribution, centered at 1400. We're going to go to 1475, and we want to know what this area is. Okay? And so from here, I can already tell you that the answer is going to be 0.2266. And that's because of the symmetry of the graph, because before we had 1325, and we knew that the area down here was 0.2266. And because of symmetry, this was 0.75 standard deviations below. I can already see that this is 0.75 standard deviations above, which means the area and the tails will be exactly the same. But we can go ahead and verify this, and we say z, we're interested in 1475. 1475 minus 1400 divided by 100 is going to be 75 over 100 equal to 0.75. If I look up the area to the left of positive 0.75, 0.75 is 0.7734. The area to the left is equal to 0.7734, which means, so everything over here, that's going to be 0.7734. So the area over here is 1 minus 0.7734. And that is equal to 0.2266. Okay. E asks, what is the probability being between 1475 and 1600? So in this picture, we're centered at 1400, and we want to find 1475 and 1600, and we want to know what is in there. Okay, so from before, we know that the area to the left of 1475 is 0.7734. Okay, and so we just need to find the area to the left of 1600 and then take the difference. So z is equal, to find the area to the left of 1600, we do z equals 1600 minus 1400 divided by 100, and we get 2.00. We look up 2.00 in our table, and we get area to the left of 2.00 is equal to 0.9772. So the area to the left is 0.9772, and we subtract off the area to the left of 1475. Okay, and we get 0.2038. Okay, and once again, what we did here is we have everything to the left of 1600, which is looks like this, and we're subtracting off area to the left of 1400. Okay, this is 0.9772, and this is 0.7734, and so the remaining piece is that, and that's 0.2038. That's part E. Oops, erase that. And finally, part F asks, what is the probability that it's between 1200 less than 1200 and 1325, okay? And I can already tell you that the answer here is also going to be 0.2038, okay? And that is, again, once again, because of symmetry. 1600 was 2 standard deviations above the mean, and 1200 is 2 standard deviations below the mean. And 1475 was 0.75 standard deviations above the mean, and 1325 is 0.75 standard deviations below the mean. So once again, the area, because of symmetry, the previous problem looked like this, 1475 and 1600, and we found this area to be 0.2038. I promise you over here it will also be 0.2038. But if we want to verify, we can do this. And so first I will find the area to the left of 1325. Okay. Z equals 0.75. The area to the left, oh, I'm sorry, this is negative 0.75. Area to the left there is going to be 0.2266. And with Z equal to 1200 minus 1400 over 100, we get a Z equal to negative 2.00. And the area to the left of that, of negative 2.0, is 0.0228. So we do 0.2266 minus 0.0228. And I can punch this out on the calculator. .2038. Okay, so I hope you can start to see the symmetry of the normal distribution and how knowing some answers helps us find other answers.